Hey, thanks for joining me. In this tutorial, I will be showing you how you can export visual scripts into ThreeJS. And you see here an example of the script. It just creates this sphere, right, that is being sliced into multiple parts by the logic here. And we will be just exporting that to Stackblitz, where we initialize ThreeJS and we are executing code via the runner of Bitbybit, which allows us to execute all the logic that you see here. So the idea is that we can just run this as JavaScript in different kinds of environments, right? The only thing that we need to take care of is we need to remove any kind of BabylonJS components that you may find on the canvas. You may not know that, but all these editors are using BabylonJS game engine. But because we have developed a core layer which is sharing the interface between ThreeJS and BabylonJS, we can sort of port those algorithms and export them and run them in different game engines. So let's get rid of this directional light component. You will see that, we won't see the light anymore and shadows. But for the rest, we don't have any components here that are coming from BabylonJS. And thus we can export this script to runner like this. So we will hit this button. We will minify the code. We will copy it. And we will go here into the Stackblitz, right? So inside of the script.js file, we have runner options where we configure some scene environment, and we execute the script here. But currently the getScript function is just returning an empty string. So let's paste the code that we've copied from the visual environment in here. And now you see that the sphere, which is sliced and looks exactly like in the script, has appeared. So now it's being rendered by ThreeJS. We don't have BabylonJS in this environment, but you see that it's even picking up the color that we defined here in the component. So in this OST shape options component, we defined that we want it to be purple, and that color is now also defining the color in ThreeJS. The difference, of course, is lighting. You may need to change it. Currently, we don't initialize scene ourselves. We allow the runner to initialize the scene for us, and then it's being returned here. But if you have your own scene, you can just pass it via the runner options to runner, and then it will be using that one to put objects inside of. So this is a short example of how to do this. But now we can also just try and return the group that is being generated by this drawAsync component and access it in the logic here. So let's use the runner components here from this category. I will say that we want to set runner result value. I will call it a sphere, and I will plug the value from the draw in here. So what that will do, it will just return the mesh or a group from drawAsync as a sphere property. So let's just export this to runner, minify again, copy. Let's go here, paste the new script. So this, you can just load via fetching some file. That's also possible. But now we need to say that we have here a result. And we will just log res.sphere, and we will check our console. So now you see here that the group has appeared, and that's a group that contains mesh for this whole object that you see on the screen, right? So this is very simple. You can output anything, numbers, meshes, whatever you want. So this is generating an output, but what about the inputs? So let's go here. And you see that there's a number slider that is controlling the bending of these splits. So if I put this bend on 10, you will see that this curvature will increase, right? And if I put it on 0, it will be flat. So this is a simple operation. In the latest release, we made it possible to customize the names. So you can just use your own names on the components to identify what they mean. So this is controlling the bending, right? Let's use that. But in order to get the inputs from Stackblitz environment, we want to use also a runner input value. So this component gets runner input value. And let's get bending property from inputs. So what we will also need to do is we will be using first defined value gate to indicate that we want to use the first value that we get from these two components, which is defined. And in this Bitbybit environment, the slider will be defined. But when we will be running this code from Stackblitz, this will be defined and it will be then used, and it will overwrite whatever comes from this one. The only thing that we have to still do is plug these things in here, and we need to use this here and this like that. And you see that geometry in the background is recomputing, but that's all right? Okay, so now we've prepared everything with inputs and outputs in the script. So let's export it to runner, minify. Minification is not necessary, but then the text will just be too long maybe for being copied as an inline text. So now what we can do is we can say that we execute the script, but we also provide a JSON with a property bending, which would be then, let's say 0. So you see now our sphere is flat, right? And if you have changed it to, let's say 15, you will see that the bend will be generated, which is really extreme. So this is the way that you can use the runner, ThreeJS, and our coding editors in sync. Some scripts may exist as visual scripts, some as code, and you can export those into your own projects by using the runner technology. We also have here a Blockly environment and Monaco environment. Scripts from those two can also be exported and executed inside the runner. So this is the most simple way of how you can get Bitbybit running in your own websites. So the runner technology itself is really powerful. In this case, we're using the light version, which requires you to set up the ThreeJS yourself. You could use just simple ThreeJS runner, which would just include ThreeJS within itself, but usually people have their own projects, they have already ThreeJS somehow available to them, and then it's better to use it this way, just a light version. This JavaScript bundle is then much smaller, and you can then access all of the algorithms of Bitbybit. And by the way, of course, if you don't want to run scripts that are coming from visual code, you can just write your own code here by using this Bitbybit command that is maybe familiar to you from our Monaco editor. Anyway, so this is a short tutorial. It wasn't meant to be this long maybe, but I hope you understood how this whole concept of runner and visual scripts work and how you can export them to JavaScript and run it on your own websites. So if you like this tutorial, just subscribe to our YouTube channel and let's see each other in other videos. Cheers!